we have already seen the Laplace transform, which is used for continuous time system analysis. Okay. Similarly, the Z transform will be used for discrete time system analysis. Important point. Laplace transform, continuous time. Z transform, discrete time. So this is the basic difference between the two. Okay. Z transform has also got the same thing, same properties, similar type of properties which are there in Laplace transform, and it's also got one more property of region of convergence, which is important in Z transform also. We have seen the region of convergence in Laplace transform. We have seen the various conditions for region of convergence. Here also the similar condition will arises, but all those conditions will be related to the Z plane. There we have seen the S plane. So what is Z plane and what is S plane? That also we should know. Okay. In Laplace transform, okay, Laplace transform, I have something called S plane, which looks like this. This is j omega axis and this is sigma axis. S equals to sigma plus j omega. Okay. Similarly, when we go to Z transform, my Z plane will look like this, and I have one unit circle, this radius r equal to 1. I will see the stability causality with respect to this unit circle. Okay, unit circle in Z transform, j omega axis in Laplace transform. Now what is the relationship between j omega axis and that transform? See, listen this carefully. Continuous time signal, whenever you sample, the maximum frequency present there will be pi. Okay, pi to 2 pi it will be repeat. So what will happen? The any continuous time signal when you sample, it will become a periodic signal with period of 2 pi. So period of 2 pi is nothing but a rotation of 1 counterclockwise or anti-clockwise. So this will repeat after every 0 to 2 pi is same, then 2 pi to 4 pi is again same, then 4 pi to 6 pi is again same. So this full axis is being mapped to unit circle here. Okay, so this is a thing which lies between a Laplace transform and the Z transform. We will not consider the case here how the things are being mapped. Okay, when we do the when we study the filters, at that time we will see how the continuous time filters are converted to discrete time filters. At that time this mapping is useful. Presently we should know that whenever we sample a continuous time signal, the maximum frequency present will be there, maximum frequency will be present will be 2 pi. So it will not be more than 2 pi. So every time if it is more than 2 pi, then it is repeats. Okay, so 2 pi to 4 pi is same, 4 pi to 6 pi is again same. Now let's see the basic formula for finding the Z transform. It is defined as xz is equal to summation n tending to minus infinity to plus infinity xn z to the power minus n. Okay, compared with the Laplace transform, xs is equal to integration of xt e to the power minus t dt. So xn is compared with xt, this compared with this. Okay, here z to the power minus n is called kernel. There e to the power minus st is called kernel. Integration has gone converted with differentiation. Okay, so this way the things are similarly, things are similar in that transform and Laplace transform. Okay, next thing. Now, since Z transform is a infinite power series, we can see from here this look like the infinite power series. So it should exist only for those values of Z for which the series will converge. Okay, just note. Since Z transform is an infinite power series, it exists only for those values of Z for which series converges. So these values of Z will be called the region of convergence. So whatever the values of Z which satisfy this, which converges the series, those values are present in the region of convergence. Okay, this is a very important point we should remember. This is a point, this is a philosophy lies behind the finding the region of convergence in Z transform. The similar properties, similar philosophy is there for Laplace transform also. Okay, the integration, final integration should converge. Okay, it should not go infinite. Okay, next. Thus, in this only, ROC or region of convergence of xz set of all values for which xz attains finite value. Okay, simple. The region of convergence is this and similar pertaining to this particular philosophy. Okay, next. Let's find for few finite duration signals. Just write it as an example. If xn is equal to some signal -1, 2, 0, 1, -1, 3, 4. 0 is located at this point. This means this is at the origin. Okay. Then xz will be summation and tending to -infinity to infinity xn z to the power -n. This will become -1 z plus 3 plus 2 z plus 2 plus 0 plus 1 -1 z minus 1 plus 3 z minus 2 plus 4 z minus 3. Okay, so this will be the Z transform for this finite duration signal. Okay, so in this, for this particular Z transform, what will be the region of convergence if we say, see, if we put z equal to 0, that means this term will become infinite. Okay. If we put z equal to infinity, z equal to 0, this, this and this terms are becoming infinity. If we put z equal to infinity, then this term and this terms are becoming infinity. At other values of z, they will attain always a finite value. So, ROC in this case will be entire z plane except zero and infinity. Okay, we'll take few more examples. Xn equals to delta n is an impulse. Xz will be equal to summation n tending to minus infinity to infinity delta n z of minus n equal to 1. Thus ROC will be entire z plane. Whatever is the value of z, xz is always finite, which is equal to 1. Next, suppose xn is delta of n minus k. In this case, xz will become tending to minus infinity to infinity delta of n minus k z to the power minus n, which is equal to z to the power minus k. Thus ROC will be entire z plane except origin or 0. Okay. See, when we put 0, this term will become infinite because it will get 1 by 0 form. 1 by 0 form is infinity. Okay. Okay. So we have seen for finite duration signal, ROC is entire z plane, leaving the points like origin or infinity. Okay. Let's see one more problem. Problem is slightly different. Suppose xn is equal to 1 by 2 to the power n un. This is a infinite duration signal. For infinite duration signal, how to find the z transform and also how to find the ROC for this. Let's see. Xz is equal to summation n tending to minus infinity to infinity 1 by 2 to the power n un z to the power minus n. Un is a unit step. It decides that this function, this signal xn will range from 0 to infinity. So I can write this series as like this: n equal to 0 to infinity 1 by 2 to the power n z to the power minus n. Okay. Now it has become little simplified. Use the geometric, this will become like a geometric series. I can write xz as 1 plus 1 by 2 z minus 1 plus 1 by 2 z minus 1 whole square plus 1 by 2 z minus 1 whole cube plus dot dot dot. Okay. This will be equal to 1 upon 1 minus 1 by 2 z minus 1. Okay. Now what will be the ROC in this case? For this 1 by 2 z minus 1 to converge, it should be lesser than 1. Okay. That means 1 by 2 z minus 1 should be lesser than 1. For this to be lesser than 1, my mod z should be greater than 1 by 2. So thus ROC in this case will be all the circles greater than 1 by 2. Okay. So if I plot the ROC for this, it will be like this. I have one unit circle here and I have one circle of radius 1 by 2. Okay. ROC is mod z greater than 1 by 2. So it will always be outside this circle. It is enclosing a unit circle also. Okay. Understood? This is a unit circle. Now we will generalize this and see a problem and see the importance of region of convergence also. Okay. Till now we have seen region of convergence, what it is. Now the importance of region of convergence will come when we see the two different signals having the same Z transform. Then they are differentiated on the basis of region of convergence. This is a very general problem. Xn equals to alpha n un. Okay. Find xz and ROC. Solution. Xz is same as summation n tending to minus infinity to infinity alpha to the power n un the z to the power minus n. I can write xz equal to summation n tending to 0 to infinity alpha n z to the power minus n. This I'll get 1 upon 1 minus alpha z inverse, where alpha z inverse is lesser than 1 or mod z is greater than mod alpha. Okay. So under this condition, this Z transform will exist. Okay. Now for this condition, if I see in the same thing, if I see if alpha is lesser than 1, then I'll have xn something like this. One point here, then here, and here, and here, and here, and decreasing up to some point. So this will be a decreasing or converging series. If alpha is equal to 1, then xn will become unit step. All points are equal. Okay. Now, third case can be if alpha is greater than 1, then xn will be diverging and it will look like this. Okay. So we have seen the three different types of alphas. Now if alpha is lesser than 1, that means xn will converge. Okay, xn will converge, then our xz ROC will be, this is my unit circle. I will show unit circle by dotted line so that it should be clear. Alpha value is lesser than 1, that means this is my circle. This is equal to alpha. Region of convergence is outside this value. So all the points lying outside this point will be the region of convergence. Okay. Now, if alpha is equal to 1, then xz is equal to 1 upon 1 minus z minus 1. This z transform is for the unit step function. Okay, this is z transform for this. Now, is second problem will be if xn is equal to minus alpha to the power n u of minus n minus 1, okay, then find xz and ROC. Solution is similar, same type of formula again we have to use. Okay, then xz will become then we find the z transform of this. Also equal to this z transform is similar to the z transform which we have found earlier. Now, this how to discriminate. We had discriminating on the basis of region of convergence. Here, alpha minus z should be lesser than 1 or mod z should be lesser than mod alpha. Okay, that means we have seen earlier the case when the signal is causal signal, means xn is lying for all the positive values. My region of convergence is outside the outer circle, okay, outside the circle. But here the region of convergence is inside the circle. We will see this region of convergence in this case will be, this is again my unit circle. This is my circle of alpha radius. Region of convergence is inside this. Okay. So in this way we can discriminate between the two signals having the same Z transform but different region of convergence. Okay. So discrete time signal xn is uniquely determined by its Z transform xz and the region of convergence of xz. Note. Discrete time signal is uniquely determined by its Z transform and the region of convergence of xz. Okay, so we can determine any discrete time signal uniquely by these two things. We have seen for a causal signal ROC is exterior of the circle, while for the anti-causal signal ROC is interior of the signal. Okay, we will see this in more details. Now let's do one more problem. xn is equal to alpha n un plus beta n u of minus n minus 1. Okay. Find the z transform for this and region of convergence depending on the value of alpha and beta. Now in this two case arises in which one is if alpha is greater than beta and second one is alpha is lesser than beta. We will see both the cases and we will see in which case the z transform will exist, xz will exist, and which case xz will not exist. Find xz and region of convergence. Solution. Again, xz can be written as summation n tending to 0 to infinity alpha n z to the power minus n plus summation of n tending to minus infinity to minus 1 beta n z to the power minus n. Okay. Now for this series to converge, alpha z minus 1 should be lesser than 1. Okay. For this series to converge, I should write it as minus n plus n. For this series to converge, beta minus 1 z should be lesser than 1. So here my mod z becomes greater than mod alpha. Here my mod z becomes lesser than beta. Okay. Now if mod alpha is greater than mod beta, then what will happen? Now see the region of convergence for this. We have seen that for the first case when mod alpha is greater than mod beta, then what will happen? I have my plane, this is my unit circle, for the first series to converge, mod z should be greater than alpha and alpha is greater than beta. So I can draw two circles. One circle is here for beta, one circle can be drawn anywhere radius of this is alpha. So for the first case, mod z is greater than alpha, means region of convergence for the first series is lying outside. For the second series, in the same thing, region of convergence is lying inside. So we can find that there is no common intersection region of convergence. There is no single value for which full series will converge. Okay, that means xz will not converge for any value of x. Thus in this case, xz does not exist. Okay, now take the case. Now what will happen? If I draw again a unit circle, circle of radius beta is here, circle of radius alpha is here. For this thing, region of convergence is lying outside this region. Okay, for the first series. For beta series, for the second series, region of convergence is lying inside the circle. Now we can find there is some common region, which is this region, which is existing for both the series. So here there are some values for which the series will converge. Okay, So this region, or thus ZXZ will exist, and ROC will be annular ring. Okay, so we have to be careful when we are choosing the values. Okay, sometimes in this case when alpha is greater than this, at that time we have to choose. Here this thing is not there. When this condition is there, we are there. At that time we are finding there is no common value for which both the series will converge. So XZ will not exist for this. But here there are certain common values for which XZ will converge, and therefore it will exist. Okay. We will see certain families of signal and their corresponding ROCs. This just we can say notes. You can write in a form of notes. Okay, I will write here signal, and I'll write here corresponding ROC. First one is causal and finite duration. Okay, ROC is entire Z plane except Z equal to 0. Okay, the second will be anti-causal finite duration. In this case also it is entire Z plane except Z equal to infinity. Suppose if it is a two-sided signal, that means combination of causal and anti-causal both, and it is of finite duration. Then again it is entire Z plane except Z equal to 0 and Z equal to infinity. Fourth will be if it is a causal and infinite duration. Okay, then region of convergence will be circle of radius r outside this circle. If it is anti-causal and infinite duration, again it would be like a circle present inside the circle. For causal it is outside, for this it is inside. This may be having radius r. See, radius greater than r2, mod z lesser than r1. Sixth category is two-sided infinite duration. Region of convergence will be like a annular region present between the two. This is R2, this is R1. Okay, so this is the various type of signals and the corresponding region of convergence. This can come as a 1 mark question in GATE exam. Okay, directly they can ask for anticausal and finite duration signal, what is the region of convergence. So we should remember, it is easy to find also, we can always analyze this and get the result.